Hello, my dear student. Hope you are all well. Welcome to Amader Pathshala. Yes, I am here just to teach here my first paper of class 11 and 12. Dear student, yes, dear student, you just see that the slide class 11 and 12 subject higher math first paper. Today we are going to discuss differentiation higher math first paper chapter 9. Dear student, before going to discussion, we would like to say something about calculus. Heading on introduction. You just see that calculus is a very least calculation method. Its main object, principal object, just to determine derivative of a function, that is to determine the slope of the tangent of a curve of a function. In the end of 17th century, Sir Isaac Newton, who was born in 1643 BC and expired in 1727, and Gottfried Leibniz, who was born in 1646 and expired in 1716, independently invented theories of calculus and explained in details. Okay. Before going to discussion, we would like to see today's outcomes. Let's see, at the end of the lesson, you will be able to learn to explain the idea of limits, which includes variable, constant, left hand limit, right hand limit, explain the idea of slope, explain the limit of a function. Okay, then describe one-sided limit, discuss fundamental properties of limits and application, describe some special limits, discuss some mathematical problems. Dear student, now we would like to see variable. What do you understand by variable? Variable, you just see that variable is a changeable quantity. In another sense, variable is inconstant. So it differs time to time under any mathematical process. Dear student, let us suppose that the value of the price of a marker is Dhaka X. So the value of X may be 30 Dhaka, 40 Dhaka or 50 Dhaka, etc. So in this sense, here we see that the value of X differs time to time under any circumstances. So in this case, we can say that X is a variable. In generally, it is generally denoted by small letters of English alphabet like X, Y, Z, U, V, etc. Okay. Now we are going to see constant. The value of a quantity which is never changed under any mathematical process is called a constant or invariable. You just see an example like this: 1, 2, 3, pi, etc. It is generally denoted by small letters of English alphabet like small a, b, c, d, k, etc. Dear student, now we would like to see limit of a variable with the help of a number line. You just see that in the number line, a is a constant. Right side to the a indicates a plus, more than a. Left side to the a indicates a minus, that is less than a, If the value of a variable x expands or reduces from the both sides of the straight line subject to a constant a, then its position is so little distance from a, that is the distance from a, it means that absolute value of a, and less than delta. We read this alphabet symbol delta, that is absolute value of x minus a less than delta, then a is called the limit of x and the value of x is denoted by the symbol x tends to a. We read this x tends to a. There is a note, you just see that x tends to a means that x is less than a or x is greater than a, but x is not equals to a. X is less than a, it means that x tends to a minus, x greater than a, it means that x tends to a plus. Okay. Now we would like to go to the next slide. Then left hand limit. Now we are going to discuss left hand limit. You just see that when the variable x approaches to the constant a, taking all the values less than a, and the limit of f of x is called the left hand limit, and it is denoted by like limit x tends to a minus f of x equals to L, where L is the limit or limiting value of the function f of x as x tends to a minus. I think everybody is understood. Okay, now we are going to cite an example. For an example, you just see that f of x equals to x plus 3, then limit x tends to 3 minus f of x equals to limit x tends to 3 minus. It will be f, since f of x is x plus 3, so limit x tends to 3 minus x plus 3. If we put x equals to 3 minus, then x tends to 3 minus, it will be h tends to 0. Okay, dear student, you just see that then the limit will be limit h tends to 0, 3 minus h plus h. So limit h tends to 0, 3 plus 3, this is h, 6 minus h. Since the limiting value h tends to 0, so it is h is a positive integer like 0.00001. Okay, so it will be 5.99999 something. So it is nearly approaches to 6. So the limiting value of f of x equals to, in this case, 6. Okay, my dear student, now we would like to see right hand limit of a function. You just see that this is the a, right side to the a indicates x tends to a plus. We have already mentioned earlier, when the variable x approaches to the constant a, taking all the all the values greater than a, then the limit of f of x is called the right hand limit, and it is denoted by limit x tends to a plus f of x equals to L, where L is the limiting value of the function f of x as x tends to a plus. Okay, my dear student, now we are going to see an example of right hand limit. You just see that for an example, f of x equals to x plus 3, then limit x tends to 3 plus f of x. So as before, limit x tends to 3 plus f of x is x plus 3. If we put as before, putting x equals to x plus 3, then say since x tends to 3 plus, it will be h tends to 0, where h is greater than 0. Limit x tends to 3 plus h plus 3, limit h tends to 0, h 6, 3 plus 3, this is 6 plus h. Since the limiting value of h is 0, so it's 6 plus 0 like this. So the limit of this function is 6 when x tends to 3 plus. Okay, now we are going to the next slide. Now we are going to discuss one-sided limit with the help of an example. Dear student, you just see that let f of x equals to square root of x minus 3. Here f of x is defined for the right-handed number from x. It means that f of x is defined only for x is greater than 3. I mean x is f of x is defined when x is greater than 3 plus, right? Okay. On the other hand, we can say that f of x is undefined only for the left-handed number from 3. That is, x is undefined only for x less than 3. On another sense, we can say like that f of x is undefined when x is less than 3 minus. Then limit x tends to f of x equals to limit x tends to root x minus 3, since f of x is x minus 3. Now again, as we put x equals to 3 plus, since x tends to 3 plus, so h tends to 0. Here h is greater than 0. You just see that this plus 3 and minus 3 will be vanished. Okay, square root of h is a positive quantity. Square root of any positive quantity is positive quantity like this 0.000001, and the root of square root of this is very small number, very small quantity, which is nearly approaches nearly to 0. That's why the limiting value of f of x is 0 when x tends to 3 plus. Now we would like to see, but limit x tends to 3 minus, In this case, f of x equals to x tends to 3 minus square root of 3 minus, if we put again as before x equals to 3 minus h, since x is equal to 3 minus, that is why x equals to 3 minus h. So it will be h tends to 0 where h is greater than 0. That is why then the limit will be limit h tends to 0 square root of 3 minus h minus 3. This plus 3 and minus 3 will be cancelled. So we get just same, we get limit h tends to 0 square root of minus h. You just see that square root of minus h, it means h is a positive quantity. We know that which is undependent, as the square root of any negative number is an unreal number, that is why it is undefined. So this type of limit is one-sided limit. One-sided limit means that it is defined in one side and undefined is another side. That is why this limit is called an one-sided limit. Okay. Dear student, we are going to the next slide. Now we are going to see the idea of slope. Okay. Let p of x y and the qx plus y and pxy and qx plus delta x and y plus delta y. You just see that in the adjoining figure, these 2 points be on a curve y is equal to f of x. You just see that this is the relation number 1, where the small changes of x and y are delta x and delta y respectively, which is represented on the figure like this. This line represented delta x, this line represented delta y. Then from y 1 y plus delta y equals to f of x plus delta y. This is the relation number 2. Now 2 minus 1 implies y plus del y, in the left hand side y plus del y minus y equals to f of delta x minus f of x. You just see that in the left hand side this plus y and this minus y will be vanished. So in the left hand side it will remain only delta y. In the right hand side f of x plus delta x minus f of x. Okay, we are going to the next slide. Or delta y equals to f of x plus delta y, delta x minus f of x. Since delta x is greater than 0, so we are dividing both sides by delta x. Delta y by delta x equals to f of x plus delta x minus f of x by delta x. Here we see that delta y by delta x is the rate of change of y with respect to x. If delta x tends to 0, then what will be happen? You just see that if delta x tends to 0, limit in the left hand side limit x tends to 0, delta y by delta x, limit delta x tends to 0, in the right hand side f of x plus delta x minus f of x by delta x. This is the relation number 3. What the left hand side of 3 is the rate of change of y with respect to the small change of x, which is the slope of the tangent of the curve of y is equal to f of x at the point x and x comma y. And the right hand side, this part right hand side of 3 is the derivative of f of x, and it is denoted by ddx of y. We read this ddx of y. You must keep this, you never think that as a fraction dy by dx, numerator and denominator, you never think like this. You must read this ddx of y. Okay. So ddx of y equals to limit delta x tends to 0, f of x plus delta x minus f of x by del x. Okay. Then we say that if we write delta x equals to h, then we get as follows: dy by dx equals to limit h tends to 0, f of x plus h minus f of x by h, which is a special limit of differentiation. We treat this as a formula of differentiation. You just see that we use the symbol ddx of y, ddx of f of x, f dash x, y dash y1 etc. to understand the derivative of f of x with respect to x. Okay. Dear student, you just see that now we are going to see a limit of a function with the help of an example. Let f y is equal to f of x equals to x square minus 4 by x minus 2 be a function which is represented, this line represented the function f of x equals to x square minus 4 by x minus 2. Okay. You just see that this function is defined defined when x is greater than 2, but if x equals to 2, if x is defined, x is greater than 2 or x is less than 2, but if x equals to 2, it is undefined, because you just see that 2 square minus 4 by 2 minus 2, that is 2 square minus 4 equals 2 square minus 4 minus, that is 4 minus 4 by 2 minus 2 means 0, 0 by 0 by, it is indeterminate part, that is why it is undefined. So we can say that this function is defined when x is greater than 2 or x is less than 2. That is why we are putting some nearest value of 2 in x, that is we are putting some values of x less than 2 or x greater than 2. Then the respective values of y as follows: if x greater than x less than 2, that is if x less than 1.9, then we get f of x is equal to 3.9. If x equals to 1.99, then we will get f of x is equal to 3.99. If x equals to 1.999, then we get the value of f of x is 3.99. You just see that 3.99, 3.9, 3.999, these values approximately to 4. So now we are going to see if x is greater than 2, then some values, if x equals to 2.1, then f of x equal to 4.1. Again, if x equals to 2.11, then f of x equal to 4.11. Again, if x equals to 2.111, then we will get f of x equal to 4.111. These all the values 4.1, 4.11, 4.111, these are approximately 4. So if the variable x is less x tends to 2 minus or 2 plus, then there will be f of x tends to 4 in both the cases. Okay. So you just see that limit, there are two nodes. Number one, limit f of x tends to f of x exists if limit x tends to a minus f of x and limit x tends to a plus f of x both exist and their values are equal. You just see that. And second one, limit x tends to f of x does not exist if limit x tends to a minus f of x or limit x tends to a plus f of x is indeterminate and both are unequal, where limit x tends to a minus f of x and limit x tends to a plus f of x are the left hand side and the right hand side limit of f of x respectively. Okay, dear student, I think everybody is understood. Now we are going to the next slide. We are going to see an example of the limit of the function. For example, if f of x equals to x square plus 3, then limit x tends to 3 minus f of x, then limit x tends to 3 minus, since f of x is x square plus 3. Now if we put as before x equals to 3 minus h, since x equals to 3 minus, that is why it will be h tends to 0 where h is greater than 0. And after putting the values, limiting value of h tends to 0, then we will get 3 square plus 3 equals to 12. So in this case we get the limiting value of f of x is 12 when x is greater x tends to 3 minus. Okay, dear student, we are going to see another one. If in this case again if f of x is equal to x square plus 3, then limit x tends to 0 3 plus f of x limit x tends to 3 plus, since f of x is x square plus 3, then limit again as we put x equals to 3 plus h, then limit x since x tends to 3 plus, so it will be h tends to 0. After putting the limiting value h tends to 0, we get the limit of the function 3 square plus 3, that is 9 plus 3 equals to 12. In this case, we see that the left hand limit and the right hand limit both exist and equal. So the limiting value of f of x equals to 12 when x tends to 3. We can say like this. Okay. Now we are going to see the next slide, fundamental properties of limit. Fundamental properties of limit. You just see that there are some fundamental properties of limit. Limit x tends to a, f of x plus minus g of x equals to limit x tends to f of x plus minus limit x tends to f of limit x tends to a g of x. Second one, limit x tends to a f of x into g of x equals to limit x tends to f of x into limit x into a g of x. Third one, you just see that limit x tends to f of x by g of x, this limit will be distributed to the numerator and denominator. That is why we can write down like this, limit x tends to a f of x by limit x tends to a g of x. Fourth one, limit x tends to a k into f of x equals to k into f of limit x tends to a f of x, where k is any constant. Okay. Now we are going to see some special limits. Dear student, you just see that special limits. You just see that let a p b. We are explaining this with the help of a diagram. Let a p b be an arc of a circle with center O. You just see that the radius OP bisect the chord AD, that is bisect the chord AB, that is AD equals to BD. Again, the tangent AC and BD drawn at the points A and B intersect OB produced at the point C. So, this OP bisect the arc APB. So, P is the midpoint of the chord of the arc APB, and D is the midpoint of chord AB. Again, when two tangents are drawn from an external point, then the two tangents are equal. You just see that. So, AC equals to BC. From the figure we can write down easily chord AB less than arc APB less than AC plus BC. That is why from the figure we have written like this, chord AB less than arc APB less than AC plus AB. Again, D is the midpoint, that is why we can write down chord AB equals to 2AD. Since P is the midpoint of the arc APB, so we can write down arc APB equals to 2 arc AP. Again, AC equals to AC equals to AB, that is why AC plus BC equals to, you can write down 2AC. Okay, then you just see that 2AD less than 2 arc APB less than 2AC. Now we are dividing both sides by 2, that is why it will be AD less than arc AP less than AC. So, since OA is a distance which is greater than 0, that is why we are dividing both sides by OA. AD by OA less than arc AP by OA less than AC by OA. Okay. You just take a look in the figure I mean in the right angle triangle AOD. AD is the perpendicular, OD is the base, OA is the hypotenuse, and angle is x. So, the ratio of sine is perpendicular by hypotenuse, that is AD by OA. So, you just see that in the right angle triangle we can write down AD by OA equals to sine x. We have learned a formula like this, S is equal to r theta. S is the length of the arc, r is the radius, and theta is the angle subtended at the, theta is the angle at the center subtended by the arc. So, AP is the arc, OA is the radius, angle this angle x angle. So, we can write down arc AP by OA equals to x. From the right angle triangle OAC, you just see that from OAC, you just see that AC by OA equals to tan x, perpendicular by base. AC is the perpendicular and OA is the base. That is why tan x is equal to AC by OA. You just see that this is the relation number 1. Now, if we divide both sides by sin x, then what we will get? You just see that we will get 1 less than x by sin x less than 1 by cos x, or if we write down, if we take reciprocal, then it will be then due to reciprocal less than will be greater than will be less than. So, 1 greater than sin x by reciprocal means numerator will be denominator, denominator will be numerator. That is why it will be sin x by x, less than will be greater than, it will be cos x by 1, that is cos x. Now, if we write down in reverse order, then it will be cos x less than sin x by x less than 1. Okay. Now, since x is a radian angle, if x tends to 0, then limit x tends to 0 cos of x less than limit x tends to 0 sin of x by x less than limit x tends to 0 1. Since limit x tends to 0 cos of x, if we put the limiting value of x equals to 0, cos 0 it is 1. Then limit x tends to 0, x sin x by x equals to, it will be 1. We see that in this case limit x tends to 0, sin x by x lies between two real numbers 1 and 1. That's why you can write down limit x tends to 0, sin x by x equals to 1, and its reciprocal value must be 1 with the help of the fundamental rules of limits. Okay, which is a special limit. We use this as a formula. Again from 1, sin x less than tan x, we have already determined a relation which indicates relation number 1. If we divide both sides by tan x, then it will be cos x less than tan x by tan x less than 1. You just see that if we make calculation as before, then we will get a relation like this, 1 less than limit x tends to 0, x by tan x less than 1. So we can say that as before, limit x tends to 0, x by tan x equals to 1, or limit x tends to 0, tan x by x equals to 1, which is a special limit we also use as a formula. Okay, now we would like to see some more special limits. Limit x tends to 0, e to the power x minus 1 by x equals to 1. Second one, limit x tends to 0, x to the power n by a to the power n by x to the power x minus a equals to 1. Third one, limit x tends to 0, ln 1 plus x by x equals to 1. Fourth one, limit x tends to 0, 1 plus x whole to the power 1 by x equals to 1. Fifth one, limit x tends to infinity, 1 plus 1 by x whole to the power x equals to e. We all use this as a formulae. Okay, next one, we would like to see a mathematical example, mathematical problem. Evaluate limit x tends to x to the power 5 by 2 minus a to the power 5 by 2 by a to the power x to the power half minus a to the power half. You just see the solution. Dear student, limit x tends to 5 by 2 minus x to the power 5 by 2 by x to the power half minus a to the power half. We can rewrite this x to the power x tends to a, then x to the power half minus a to the power half whole to the power 5, x to the power half whole to the power 5 minus a to the power half whole to the power 5 by x to the power half by minus a to the power half. Okay, we are considering that x to the power half is y to a to the power half is b. Then it will be limit will be changed like this, y tends to b. Then limit y tends to b, limit y to the power b minus b to the power b, b to the power 5 by y minus 5 y minus b. You just see that we have learned this formula from the special limit. Limit x tends to a, x to the power n minus a to the power n by x to the x minus a equals to n into a to the power n minus 1. Then it will be 5, n is 5 and a is n minus a is b, so it will be b to the power 5 minus 1, 5 to the power b is a to the power half whole to the power 5 minus 1, this is 4, so 5 into a square. Okay, dear student, we are going to see just we are going to give you some homework. Evaluate the following limits, like limit x tends to 0, 5x by x, limit x tends to 0, second one tan ax by sin bx, third one limit x tends to 0, sin 7x by minus sin x by sin 6x, limit x tends to 0, 1 minus cos x by x square. Okay, thanks to all, stay safe and take care.